This video is the first derivative test. So after we've determined the intervals on which a function is increasing or decreasing, it's really not difficult to figure out where the extrema are for that function. So for example, in this figure here, which is the problem we just did in the previous video, this function has a relative maximum at the point 0, 0 because it's increasing directly before it and decreasing directly after it. So anytime we have our test points and we're increasing here and decreasing here, that has to be a maximum. If we're decreasing here and increasing here, that has to be a minimum. So you can see we're decreasing and then we're increasing. So this is really cool. We can use this now to determine where our maxima and minima are without any, ifs, ands, or buts, right? The first derivative test. What the first derivative test does is it says that if the derivative changes from negative to positive, which means we're going from decreasing to increasing, then f has a relative minimum at that point. If the derivative changes from positive to negative, then it has a relative maximum, right? Because it's going up, then it's coming down. So that gives it a relative maximum. If f of x is positive on both sides of c or negative on both sides of c, then it's neither a relative max or a relative min. In these examples you can see here, relative minimum because it's decreasing then increasing. If we're increasing and then decreasing, that's obviously a maximum. And here we're both increasing on both of them, so this is not a max or a min. Same deal if we're decreasing on both sides. So let's use this first derivative test to find the relative extrema on f of x equals 1/2 x minus sine x on the interval from 0 to 2 pi. Now, first thing we need to note is that f is continuous, okay? So we can take the derivative, and the derivative of 1/2 x is 1/2. The derivative of negative sine is negative cosine. Now, to determine the critical numbers, we're going to have to take this and set it equal to 0. All right. So what do we have? We have 1/2 minus cosine x equals 0. We need to add cosine x to both sides. We get cosine x equals 1/2. So then we ask ourselves, okay, well, where does the cosine of, or the cosine of what angle equals 1/2? We look at our unit circle. Remember, cosine is the x value. So when is the x value 1/2? It's at pi over 3 and what is that? 7 pi over 3, sorry. No. 3, 2, 3, 4, 5 pi over 3. Sorry, I had a moment there. So those are our two critical numbers. Now, notice there's no point where the derivative doesn't exist. So we can conclude that these two are the only critical numbers. So what are we going to do? We're going to make test points, right? Now, you can see this as a table. I don't tend to like tabular methods for this. I think the number line is much more effective. So let's actually look. We can see these intervals and then look at our tests, and you can see which one you like better. So our test values, or not our test values, but our critical numbers are pi over 3 and 5 pi over 3. So remember, we're on a specific interval, right, from 0 to 2 pi. So I need a number that starts at 0, this ends at 2 pi. I need a number between 0 and pi over 3. Let's say pi over 6. All right, well, let's use the one that they used here, pi over 4. And then a number between pi over 3 and 5 pi over 3, which would be pi. And then a number greater than 5 pi over 3 but less than 2 pi, we could use 7 pi over 4. So if I come and use 1/2 minus cosine x, 1/2 minus cosine x, that's my derivative. And I'm going to plug these values in. I'm going to get 1/2 minus cosine x, which is root 2 over 2. I get 1 minus root 2 over 2. Well, root 2 is bigger than 1, so this is going to be a negative number. So this means I am decreasing. If I plug in pi, I get 1/2 minus cosine of pi, and cosine of pi is just what? -1. So I have 1/2 minus -1, which is 1/2 plus 1, which is a positive number, which means we are increasing. So that tells me that pi over 3 is a relative minimum. Now, over here, the number bigger, we're going to say 1/2 cosine of 7 pi over 4, which is, well, cosine of 7 pi over 4 is root 2 over 2. So minus root 2 over 2. Once again, just like it was before, this is negative. Therefore, we went from increasing to decreasing. So we have a relative maximum. So we can see that this is going to be, how it shakes out. We have a relative min here and a relative max here. So if you have any questions about using the first derivative test to determine relative max and min, please just shoot me a reminder or ask questions in class.